welcome to Sri Chaitanya. This is Umasankar, All India IIT Coordinator. Welcome to Vector Algebra classes. This is lesson number 10 in Vector Algebra. So far successfully we have completed 9 lessons. In 9th lesson, we completely concentrated on vector product of 2 vectors. Previously, in 7th and 8th lessons, we have concentrated dot product and problems on dot product. First 6 lessons, mainly we have focused on properties of vectors and applications of the properties of vectors. In this lesson, in lesson number 10, today we are concentrating the scalar triple product of the vectors. After that, in lesson number 11, we are concentrating the vector triple product of the vectors. Again, my friends, please don't forget to check the description. There I am providing the links of the previous lessons, and sometimes I may provide the very good assignments and important question papers also to strengthen your mains and JEE advanced preparation. Through this lesson today, I am concentrating on the basic definition of scalar triple product or box product, simply I can say, and its properties and geometrical interpretation, volume of the parallelepiped and tetrahedron, volume of the tetrahedron. My friends, here just I am giving the formula and some of the basic concepts. They are very, very important for you to revise all entire vector algebra, especially for scalar triple product. This video is sufficient. But my suggestion would be, please solve and get the proofs of those particular results. Then only you will get the complete awareness. But this is not the time. Through this video, providing all these things becomes a laborious process. That's why I am not concentrating that part. Here I am giving the more important use of that particular formula, especially in scalar triple product. Now, my friends, what is the definition of scalar triple product? Nothing but box product or mixed product. See, suppose A bar, B bar, C bar are 3 vectors, and A bar, B bar, C bar are any 3 vectors, and if angle between A bar and B bar is theta, and angle between A bar cross B bar comma C bar is phi, then A bar cross B bar dot C bar is equal to, please, here A bar cross B bar dot C bar, you read like that. Don't read as A bar cross B bar dot C bar, because B bar dot C bar is a scalar. Never apply a dot product or cross product between a vector and scalar. Okay, so here 2 vectors matters. One is A bar cross B bar dot C. Okay, so this is mod A bar, mod B bar, mod C bar, sin theta cos phi. Okay, where theta is what? Angle between A bar and B bar, and phi is what? Angle between A bar cross B bar and C bar. And simply it is denoted with the box ABC. Somebody, they will separate them by commas. In some authors, they never separate them by commas. They simply put them in a box bracket, like a square bracket, like like this, and they will write A bar, B bar, C bar, or simply they can call it as box ABC. Okay, or box product. Actually, geometrical interpretation of box ABC is what? Volume of the parallelepiped at which A bar, B bar, C bar are what? Coterminous edges. That means this is a situation. You imagine a parallelepiped like this. You imagine a parallelepiped like this. Suppose this is. You imagine a parallelepiped like this. This is OA, B, C. This is A bar, B bar, C bar. If A bar, B bar, C bar are coterminous, coterminous means for all the vectors, the initial point was same, or initial point is same. That's why they are called coterminous edges. If A bar, B bar, C bar are like this, and this is called a parallelepiped, to find the volume of this parallelepiped box ABC. So it is denoted with capital V. It is box. It is a number. It is a scalar. It is what? A scalar. Okay. And my friends, actually, A bar dot B bar cross C bar is nothing but A bar cross B bar dot C. Both are same. Both are same. Or I can also write it as box ABC equal to box BCA equal to box CAB. Try to understand the rotation. ABC, BCA, CAB. In an order, in a specific order. Whenever I am applying the same order, then only the boxes are equal. Okay. And suppose if I have changed the order, that becomes what? A bar dot B cross C equal to minus A bar dot C cross B. That means box ABC equal to minus of box ACB. If I have changed any two vectors in between them, then automatically sign will change. How to find the box product? If three vectors are given for me, box ABC is nothing but determinant A1, A2, A3, B1, B2, B3, C1, C2, C3. Actually, this holds good what? By the properties of determinant only. You know that determinant of A equal determinant of A transpose. And moreover, if I have changed the corresponding rows or the corresponding columns, then determinant value unaltered. Like that, determinant of ABC equal to determinant of A1, A2, A3, B1, B2, B3, C1, C2, C3 equal to determinant of B1, B2, B3, C1, C2, C3, A1, A2, A3, C1, C2, C3, A1, A2, A3, B1, B2, B3. So all the properties behind the screen of this particular area applicable from the properties of the determinants only. Actually, if I have changed any two rows or columns, automatically the sign of determinant will change. Like that, if I have changed the direction of any two vectors, that means order of two vectors, a determinant of ABC or box ABC equal to box minus box ACB, because I have changed BC with CB. That means what? If I have changed any two rows or two columns, automatically value of the determinant will change, sign will change. The same applicable here. So behind that, the properties of the determinant concepts will involved in the picture. Now coming to A bar is equal to A1 L bar, A2 M bar, A3 N bar, not IJK. L bar, M bar, N bar. They are not unit vectors. There are some other vectors. A1 L bar plus A2 M bar plus A3 N bar, B bar, similarly C bar. Then box ABC is equal to determinant box LMN. This is important. This is general. But box IJK is equal to 1. That's why it is not necessary to write A bar is equal to A1I plus A2J plus A3K, B bar equal to B1I plus B2J plus B3K, C bar. This is generalized version. So because box IJK is what? I box IJK, but triple product of IJK is what? I cross J dot K. I cross J is K, K dot K equal to 1, like that. Okay. So if where element are what? Non-coplanar vector, this is important. So whenever I am giving any particular formula, my suggestion would be, please focus on the basic and terminology and conditions given on that particular vectors. Whenever box ABC equal to 0, then simply we can say that the vectors are coplanar. This is the best litmus test to check the vectors are coplanar or not. It is easy way to check the given set of vectors are coplanar or not. Okay, my friends. Now coming to, suppose if box ABC is greater than 0, then I can say that the vectors will form a right-handed system. And if box ABC is less than 0, the system will form a left-handed system. Right-handed system means A bar cross B bar, A dot C bar. That means A bar, C bar is always perpendicular to A bar cross B, A bar and B bar. And moreover, A bar, B bar, C bar are non-coplanar vectors. That means right hand thumb rule. A box ABC less than 0 means left hand thumb rule. That means C bar is perpendicular to the plane of A bar and B bar, but it is in the reverse below direction to the plane of A bar and B bar. Okay. And if IJK are unit vectors along X, Y, Z, box IJK equal to 1, and box K A bar, B bar, C bar equal to K into A bar, B bar, C bar. This is important because in a determinant, if I have multiplied the elements in any row or column with some scalar, then resultant of the determinant is equal to K times resultant of the original. Like that property I have applied. And box of A bar plus B bar, C bar, D bar equal to box ACD plus box BCD. I know from the determinant that if any row or column contains sum of two elements, I can express it as sum of two determinants of same size. Like that properties here we can apply in a vector. Say, my friends, what I said in the beginning of our classes. Here we are now in vector algebra space. In a vector algebra, just like in a real number system, we are now learning the notations, the language, the formulae, the fundamentals, almost just similar to our previous real number system. The same thing in a different notations only we are practicing. Concept and theme behind the screen is same. Okay, and moreover, if OABC or what? A tetrahedron, if OABC is a tetrahedron, then volume of the OABC is equal to 1 by 6 box ABC. To be more precise, 1 by 6 mod box ABC is to be more precise. But suppose if volume is negative, that is vector, that indicates what? Where origin lies, above the plane of ABC or below the plane of ABC indicates. That is the only matter here. That means whether the origin is like this or not, or if it is along here like this or not, that is decided by the sign of box ABC. Okay, and if A bar, B bar, C bar, D bar or what, position vectors of the vertices of a tetrahedron, then 1 by 4 A bar plus B bar, not box, this is 1 by 4 A bar plus B bar plus C bar plus D bar indicates what? The center of the tetrahedron, or I can say centroid of the tetrahedron. Centroid of the tetrahedron is nothing but center of the tetrahedron. These are all of the basic important formulae in with the help of scalar triple product in vector algebra. Okay, my friends, see. Now, please remember, box A bar minus B bar minus C bar minus A bar equal to always 0. Okay. Similarly, box A bar plus B bar plus C bar plus A bar equal to 2 into box A bar, B bar, C bar. It's simple. Here in the first result, actually it is what? 1, minus 1, 0, 0, 1, minus 1, minus 1, 0, 1 into box, I think ABC, A bar, B bar, C bar. But this is 0, 0 into something is equal to 0. Whereas in second one, this is 1, 1, 0, 0, 1, 1, 1, 0, 1 into box ABC. After simplification of this, you will get 2 into box ABC. So just determinant. So entire triple product of vectors is nothing but applications of determinants. So in general, in entrance examination, than asking direct questions from the determinants alone, we may expect very good questions with respect to the vector algebra and applications of the volumes, etc., its areas, and etc., etc. Okay, in through what? Through scalar triple product. Okay, or box product. Okay, my friends, if you like this video, please share and subscribe my channel, and please don't forget to press the bell icon, and you will get the continuous notifications, and we will meet with the next lesson soon. Thank you.